Good evening, everyone. So let's wait just 2 minutes. If anybody else joins, then I'll start. Shall we start now?
Yes, we can start.
Good evening, everyone. I'm Ayushi Pandey. So, welcome to the day two. So, today we have computer vision and classification. So, what today actually is that image classification use neural network and KRAS. I will tell you what neural network is, and I will tell you how can you train a simple image. And by the end of this lecture today, I think most of you will be able to understand what neural network is and how can you train your images. And if there are existing model for image recognition, training neural network, and classification using SVM. So yesterday, Anil sir told you like he showed you this image and he told you like what kind of problem it is. So if we want to identify cat or dog, so it is a classification problem. So if I want how much is the value or what is the value, then it's regression. It is weird. So there may be some issues and we want to detect anomaly. And if we group it is clustering and making decision and no data, it's reinforcement learning in which the computer, the system, what it does, it's using the existing model and then combining it with the new model and learning it again and working it. It's like a child or it's like a pet who learns your language, who learns your behavior and do accordingly. So we have to basically majorly divided as supervised and unsupervised. So supervised is that you are telling the system, okay, these are the things which has to be categorized. You are telling that you are telling the category or the solution to the system initially. Then the system is learning, okay, so if the problem is this is solution. If the problem is X, the solution is Y. And then you are asking, okay, what is the question? And according to the system is learning, so according to his knowledge, he will tell you, okay, this is the solution. And in unsupervised, the solution is not given exactly, but the system runs learns accordingly. So image recognition, like you and I can understand what the image is, but how a computer will understand. So this is the image of a dog, or if we take uh, any of the image for any animal or anything. So what will happen? There is will be a neural network. That neural network will be learning initially on some data set, and from that learning, when you will give this image to that model to test, so what will happen? It will give you, okay, so this image belongs to a dog. And or if there is a image of a flower, so the neural network will say, okay, so I think according to my knowledge, the image is of flower, so the output will be flower. So we have a situation that there is a place, for example, metro station or some place or some area or some hotel or some connection where pets are not allowed. So there is a sign, pets not allowed. And what is happening, that if we like if people are standing, that takes a lot of resources, but we can uh, there can be a system, there can be computer robots to detect if animals or if some pets, if dog or cat are coming to that area or not. So how will computer understand that? Like we can't just tell him, like the computer has to run. If a person is standing, that person knows, he has learned something, okay, this sometime that this is cat, this is dog, it's not allowed. But how will the system understand that? So for this we have so this is a classification, and we will be learning it today using neural network. So, what exactly a neural network is, or we can say it is an artificial neural network, neural net, which is based on our biological brain neurons. So, you can see, I hope this image is clear, like this image is visible. Okay, I can't zoom on it. So, I hope it is visible to you all. Okay, so what exactly artificial neural network is? So artificial neural network is derived from biological neural network that develops the structure of a human brain. Like our brain, we have like in our brain, we have this neuron. So this was the inspiration behind the neural network. So neuron in human brain are interconnected to one another in various layers. And similarly, like this is for the single neuron. Similarly, these neurons can be interconnected, like there is a layers of connection in our brain, and to learn. And each of these layer is known as nodes. So this is a single layer, which is also known as perceptron. So like our brain has multiple thousands and thousands of neurons connected. So we can have a deep like many layers connected, a deep neural network, which has many layers. So in ANN, this cell, this is a human brain neuron. So this is a biological neuron, and this is your artificial neuron. So as you can see, you have these synapses here. Okay, so this is synapse. So this is the connection. This is the input. Then we have a weights also here. We have some weights to represent. So like this is a weights. So this is for inputs. Then this is the main neuron. Okay, so where what happened? This is a normal processing unit, and then we have output, which is also known as exome, like in typical uh, biological term. And this represent our output. So we have an input here, and then there is some processing going on, and there is this output. So the input layer accepts input in several different formats provided by the programmer. And then we have different hidden layers. We can have n number of layer, like we have thousands of neurons connected with each other. So similarly we can have that. And hidden layer in between input and output. So this is your output and this is your input. So like this is a single neuron, so we can have many layers connected, and we can have an input and output. And in between that we can have multiple layers which are connected together, and that it performs calculation, which is hidden to features and pattern. And then we have our output. As the name suggests, it gives the computation which it got from the previous layer. So properties of ANN, many simple neurons like threshold switching unit, like it's like properties are like it is inspired from this. We can have single layer, we can have multiple layers, many weighted interconnection among units. It perform highly parallel distributed processing. Like we can do multiple things at one time, and learning by tuning the connection weights. So in neural network, we have one thing is known as perceptron. So this is a single layer of neural link. So if we have a single layer, it is known as perceptron. And if we have multiple hidden layers, so it converts into a multiple. So you must be thinking, okay, so this is an image, and what does this exactly means? So like our brain, in the brain we have this to represent input. So this is the input part, then this is the calculation part, where this is the central processing part where the calculation is being made, and this is the output part. So what happened? It begins with, so we have inputs, we have some values as input. It's always in form of a number, and we have, so we can have X number of input, and then there are some weights associated with it. So exactly there are weights associated with it. And so what will happen initially, the multiplication of this designated weight with the designated input will take place, and then there will be a sum. So, and this is known as weighted sum. So now what happened? We have multiplied the input with the weight, and then we have a weighted sum. And then this sum has, and then some activation function is applied to the sum, and there is this output. So the work of activation function is to have the output to make sure that the output is between either 0 or 1, or between -1 to 1. Okay, and among that, the answer, among that, we can guess what is the answer of it. So what happened? The process happened. So x1, then it is multiplied, then there is a weighted sum, activation function is there, and then there is an output. So the output came out to be wrong. So what will happen? It will make the system will say, okay, the output was there was some scenario given, and the output does not match with that scenario. So what will happen? It will go back, and then these weight will get adjusted again, and then the process will continue. So this ReLU and softmax are the activation function, and softmax is usually the last activation function to normalize the output. And the output is always in category 0 to 1, which is a real value, or it can be between -1 and 1. Okay, so this is one of the example of neural network. So we have these input, age, gender, stage. So, and then these are the weight associated with it. And in the hidden layer, the computation is happening. So if we have multiple layers, so multiple weighted multiplication and activation will take place. Then the activation, some and activation happen here, and some and activation happen in this layer. And then what happened? Again, the weighted sum was, then they were weight associated with it, and then it was multiplied, and there was this sum of this. Like it is multiplied 35 into zero point 0.6, then 34 into zero point 0.6, 2 into zero point 0.1, 4 into 4 into zero point 0.7, and all this is added. Then there is this activation function, then it is calculated according to that. So I'm not going into deep maths because it will take a lot of time. So this is basic. So what happened? There is this output. So while you're training, you always train your model giving the classification. So for these input, output will be there. So it always compares so that our model get trained perfectly. So here the output is 0 0.6. What happened? The output came out to be 0 0.1, but the answer was 0 0.6. So our system knows, okay, while training, this was the output, but it was not the desired output. So it will back propagate. That process is known as back propagation. And the weights will get adjusted, and this whole method of multiplication, weighted sum, and activation will take place until the desired output is there. And then if the output is 0 0.6, so I told you the output is between 0 and 1. The output is 0 0.6, and which is probability of being alive. So these are the inputs which are independent variables. Weights, we have hidden layers. We can have n numbers of hidden layers. Then we have weights for final, and then this is the final activation, and then output, which is a prediction, which is we are saying it dependent because it's always dependent on these values. Okay. So this is a deep neural network. It contains 5 layers. So in deep neural network, what happened? First, these 2 layers get computation happen. Okay. So the sum will happen, and this is for the activation function. So the sum will happen and the activation function will take place. So this will happen here. Then whatever will be the output, for that it will be feed into this layer. Then the computation between these two layers will happen. Okay. Then whatever the output is, it is feed for this layer input. And then the computation between these two layers will happen. Then the computation for these layer will happen. These layer and finally the output. Okay. So this is the example. We are using Keras. It's the uh, one of the libraries used for finding for neural network. And you can see this is the activation. I'm telling you, we have this sigma is activation function. So this we have an activation function known as ReLU. So I told you that we'll be doing the classification of cat and dog. So this is our data set. So for classification, whenever we are doing classification, whenever we are doing anything in machine learning, or whenever we are training our machine, so what we want, there are few steps. There are few steps, and so one of the first step is we input our data set. So we have a data set. We always take a data set because we want to train our we will train our machine learning model or the deep learning model or whatever model we are taking on a data set. So our basic requirement is data sets. So step one for doing your any model for machine learning or for machine learning or deep learning or anything for training your system, we need data sets. So there is this data set in Keras, and then so this is a Cypher 10 data set. I will show you what this data set look like. So what we will do, we will load this data, and we always need X-train, Y-train, and test and train. So why we need train and test? Okay, so before this, I will show you the data set. So this is a data set. So this data set is already labeled and classified. So we have 10 class here. There are two type of classification. One is binary classification and second is multi-class classification. So this is a multi-class classification. Binary classification, we have only two class. So in multi-class classification, this is a multi-class classification, and this is the that the data set I was talking about. So this is the image of the data set. It contains multiple images, and this is the few images. So this image contain into the class of airplane. There's images in class of automobile. This is so this is class bird, cat, deer. So these images are already classified. So what happens whenever we are taking a data set, we always divide a data set into training data set and testing data set. So first we will train our model, we will teach our model, then we will test our model to know, to see if our model has been trained properly or not. So if the testing is like if the percentage of testing accuracy is high, so we'll be like, okay, now our model is ready for working. So we will predict, we will give a single image and we will predict. So the model will give you the output which we were talking about. So the data set is always divided. Whatever the data set you take, it's always divided into testing and training. And to have a good working model, we always want a data set to be randomly divided. So randomly divided. So so this part, the image part, this belongs to the X part of the data set, and the label are always the Y part of the data set. So the our data set is divided into testing and training. So in testing, these images will go, and in why we always have these are the data set. So it is always associated. The first, like this images belong to airplane, this image belong to automobile. So our data is divided. And why we have X train and Y train? Because we want our data to be divided into a few training data set and few testing data set. And these are the labels. Okay, so I will go back to the code. So I've loaded my data set, and this data set is already in the keras. And then, so this is not exactly an image. This is the value of image. Like this is the image is already converted into, we can say, so it's converted into float value, and using dividing to 255, we are converting this image between 0 and 1. And this is to convert the class vector to binary class matrix, which means that the class has been converted between 0 and 1. I'll show you when I'm doing the code that how this class has been converted. So this is the first part of doing any classification or any model training, that we load our data and we divide our data into X train, Y train, and we try it to be random. So what is happening, what we are doing? So what we are doing? Okay. Wait, I will, So, so before starting, you must be thinking, okay, what is this TensorFlow and what is this Keras? So TensorFlow and Keras are both open source end-to-end platform libraries for multiple machine learning tasks. Okay, so our TensorFlow is this for multiple machine learning tasks, while Keras is high-level neural network library, which runs on top of Keras. So for on TensorFlow. So for Keras to be run, we always need to import TensorFlow. Okay, so first TensorFlow we imported, and the Keras work on the TensorFlow. So both are open source, and but the TensorFlow is the Tensor with the help of TensorFlow you can run multiple machine learning tasks, and but Keras is for high level neural network library. Both provide high-level APIs used for easily building and training our model. But but while comparing both of them, Keras and TensorFlow, the Keras is more user-friendly and it is built in Python. So if I'm comparing both, so the Keras is the API is high level, and compared to TensorFlow, the Keras is simple and readable. Then you saw that the data set was imported from Keras in the previous. So I'll go back here. So the data set was already imported in Keras. So whenever you'll install the Keras library in your system, it will come along with a data set. So the data set in Keras is small compared to the TensorFlow. It contains large amount of data, and then uh, the Keras is written in Python, but the TensorFlow is written in C++, CUDA, and Python. Okay. So this is the basic library which you will be needing to use, and this is the basic sequential model. This is the base model, and then you need to make layers. So first you will have an input layer, then you have a layers for working, and then we'll have an output. So what will happen? Like we'll add layers. So these are the few example. We are having an input shape. So we are inputting. So the image will be input, and then we'll have one layer with the activation ReLU, and then another layer also with activation ReLU. So this is the like a code. Like I'll show you the proper code. So what exactly is happening here? So you guys will be thinking, okay, you told us about Keras and TensorFlow, but how? And you told me about the neural network, but how exactly it will work? So okay, so what is happening? I'm taking an image and I'm processing it to my neural network, which can contain n number of layers, and then it is giving me the answer, and the answer here was dog. Okay, so with the help of, so there was the ground truth, because while training, this is all happening while training. So this is training. So in training, we know that this image belongs to this specific class. So output here was dog. So so the ground truth was wrong, and using loss or error, we got to know, okay, there is a issue. So then what will happen with the help of optimizer, the weights now, which were initially taken as x, some values, it will be uh, changed, and it will be accordingly. So using optimizer, we have different optimizer. So the back propagate will happen when there is an error. So this is an error, and the neural network will train again. And then it will look again, okay, still again showing some other class. It will train until for this image, the answer is here cat, not dog. So okay, I will explain it again. So we have this image. This will go through our neural network and it will give an output. And that output will be compared to your Y train. Okay. So here, this image is cat, but the output is dog. So using the ground truth, loss or error, so it will be showed, okay, this is the issue. Now, back propagation will happen. The neural network will go back to layers, and it will go adjusting the weights using the optimizer, and then again it will calculate sum and activation, and then it will give you the output. And if then the output will match the white uh, the white training will match with the output. So at that time, okay, your model will say, okay, I have this person. Okay, so I'm ready to test. Now the testing will happen to see if the training was accurate or not. So these are the some common loss function: cross entropy for classification, mean square error for regression, L1, and many more. And these are the few: optimizer, Adam, agrad, RMS prop, stochastic grain descent, and more. So this is how we compile our model. So we are adding a loss, then optimizer, like using this loss and error, we look for the ground truth, and then matrix. So we are training our model. So using training, what we are doing. So now I've made my model. Now I will train. So for train dot fit method is used, and all the models have this dot fit method. So x train, y train, we have this batch is for dividing that, and epochs is number of time it will be trained, and then this is for testing. So for validation, and shuffle is equal to true because we want our data to be random. So we are making the shuffle to be true so that our data is as much random as possible. Now I will show you on Collab. So I will rerun it. Okay. So, so the collab is by Google. So it's a Google collab by Google, and in this, our system resources are not being used. The resources of Google are being used. So we can have different runtime. We have none runtime in which it's using normal hardware, and then we can have GPU and TPU. GPU, it can be used in normal GPU and TPU. So I'll be using GPU. Okay, and we can use for some number of time because it's a free version. It's not a paid, like there are option to buy resources for from collab, like collab pro, But for basic, it runs for some number of time. After that, even the collapse ceases. So these are the models. So these are the imports which are being used. Okay. So I told you about that loading the data set. This is my data set. Uh, and my data set was divided into X train and Y train. So we have for training we have 50,000 data, and for testing we have 10,000 of data. So totally, this data set contains 60,000 of data. And then, okay, so I want to show you how this data looks. This data is this image has been converted into arrays. So this data is not exactly image that has been converted into array. Okay, in form of these giving number, and the even the color has been converted into arrays. And then I'll show you Y train. So this is showing me 6. So these are the Y train, like this is, so the 0 1 was the first image belongs to the 6. The first image belonged to the 6th class. Okay. So each class has been given a number, like the first one was aeroplane, so aeroplane belongs to class 1. Then cat belongs to class 2, similarly. So the first image belongs to class 6. Now I'm converting this, I'm reducing the pixel value and converting, I'm trying to convert it. I'm converting the RGB value into a basic 2D value. Okay, so now I'll show you how the image looks. You can see this has been reduced between 0 and 1. All the values are between 0 and 1. Okay, so I will do the 0th. This is first image. So all has been between 0 and 1. Okay, so I have normalized it between 0 and 1. Why I'm dividing by 255? Because in RGB, in the color, the it lies between 0 and 255. Now this is the visualization. So this is the first image, second, okay. So these are the different image. Okay. So now I will run this first. Okay. So what is happening? I am finding number of classes. It will tell me number of classes. Now, first I'm making my input layer. Okay. So what I'm trying, so I'm making my input layer. It has been run. You can see it contains these number of layers, input and containing input and our hidden layers. So I'm trying to first taking my input layer and I'm trying to flatten it as much as possible. And we can have n numbers of layers. Okay. Then what I'm doing, then I'm making hidden layer. I have only 2 hidden layer here, and this is my last output layer. So I told you the activation function for last layer is always softmax. Okay. So the number of layers, the number of input layers and number of hidden layers, it always it always help you like it always depends on you when the person is coding, when the person is making model. It solely purely depend on that person, that how that person is converting, how that person is making layer. So like I had made so many number of input layer. No need to make these much of input layer. You can have 5 input layer, but some person can have 4 or 5 or 10 hidden layers. So only depends on how person is working, because when we are training, we get to know how our model is working. Like it's purely while training, while testing, we get to know that how our model is behaving, and then we change the layers to make our model work. We increase the number of layers or we decrease the number of layers. So this is the okay. So now I'm doing. I have my model is ready. Like how will my model work? Now I'm compiling my model. The optimizer I'm using Adam, and this is the loss. And now my model has been compiled. Now what I will do, I will train my model. Okay. So I'm training my model for 50 epochs, which means it will run 50 times. It will do the value 50 times. So you can see, so it's running. So it takes times. It depend number of times, and epochs you can increase or decreases. Like if you think by increasing the number of epochs, your value will change, or your accuracy will increase. See, as you can see in the first running, the accuracy was 55 and it's increasing. So sometimes increasing number of epochs. So you don't never run your model one time. You always run your model multiple times. You always run your model multiple times and the accuracy increases. So after a model has been fine, we input value and our system classifies our, so it will take time because it will run 50 times. So so I'm coming back to it. So what will happen, that after a model has been trained, we will give input image. We will give an input image, and the output will be according to that. Like the animal is being allowed or animal is not allowed. So what is happening? My that is being trained. Okay, this is training here, but this is the what happened. I load the image, then I give my image to model, like this model dot predict, and this image is being given to model, and there is this result, and then I make up that this result is the result belong to that class which I want to, which I want that class to be or not. Okay. So it will take time. It sometimes takes even hours and hours, 4 5 hours to work. So I'm continuing. Now the second statement is fair your mask policy. So what happened? Your institution is like where they want to implement wear a mask policy, but what is happening, people are not doing it, or and even they can't deploy so many number of people to check. So they have put a system. So how that system will understand? So this question is for you to do it. This is one of your homework question for you to do it, like how will it work. And but I will tell you like what can be the database and all, but you have to do it on your own. So database. So the challenge is, to we have to, we want our institution, my institution want to implement wear a mask policy, and I want somebody, like I can't deploy people, so I have deployed cameras for me to tag it. So first, the challenge is data set, because so much of data set is not available, because individually every person has to. There should be so many of data, because higher the number, higher the number of images in our data set, R is the accuracy. So, like I want my model to train like this, mask detected, no mask. So, what we can do for data set? So, first, uh, this is the data set preview. You can see this look like some it has been imposed. So yes, it has been imposed. What is happening? The data set for mask is not available. So what people are doing, they're synthetically generating data set by imposing mask. And there are few data set with mask. There are images available on internet, but you can have these images also, and all type of these data set are available on internet for you to work. And so using your keras, you can take this data set and extract the feature and run your model. So now we have few existing architecture for models, image recognition, which is Inception, V3, ResNet, VGG, MobileNet. Okay, these all are trained on. There is a data set known as ImageNet, and even pre-trained models are available for people to reuse for their own task. So what if the image category is not present in pre-trained model? So first we can use transfer learning. So what transfer learning is that in transfer learning, the machine learning method where we use the pre-trained model straight as the starting point for a new model. So like we will not initially make okay. So So in this model, I use the model as sequential. Okay. So in that, instead of this, we straight away start with, for example, VGG model. So I can straight away start with a VGG model, then add my layers to make my model better. Okay. And this is a transfer learning, which means there are existing machine learning techniques, and there are already trained, and we are using that model to train our to betterfy to make a model better. And neural network is highly dataset specific. Okay. Now, how to teach computer to understand an image? So we have two things. One is feature extraction, and second is classification. So what happened in feature extraction? We have an input image. We extract feature. We give it to machine learning classification model, and it tells you car or no car. And then second, we have there is an input. In deep learning, the feature extraction and classification happens inside our hidden layers, starting from input layer, hidden layers, and then it gives the output car or not car. Okay, so this is how these are the two methods. So this is the step. So first is feature extraction, then second is classification. So if for the machine learning program, we have to do a feature extraction, and which like we have to see, okay, right feature was extracted or not. But in deep learning, all that happen in the layers. Okay, so how features are extracted? Like for example, this is a dog. For dog, you can see like most of the dogs have downward ears, so these type of ears, these type of eyes, then the snot is bigger, the nose is bigger compared to cats, so the nose is smaller, the eyes is different, they have a different type of eyes, ears are always upwards. So these are the features which can be extracted for images, and then the classification of machine learning model can be done. Okay, now my next problem statement is, what if the data available is not image but classified? Okay, so what is classification, how it is done? Okay, so I want to do something, but that problem, the image is not available, but a data set is available which is classified. So what I will do, how I will do. The first is, what is classification? We all know that categorizing each row into something. So the having some category is known as classification. Like this is classification of waste. So this is paper waste, metal waste. So these are all categorized into properly, and they are properly separated. So our data is properly separated. Okay, so this so if we have the data that is not an image, so that will be in form of table, rows and columns. So first row belongs to this class, second row belongs to this class, and so on. So what is happening? Uh, we have two in this we have two buckets. Okay, one bucket is sick and second bucket is healthy. So we have only two class. So this is classification, binary classification problem. Okay, so this people we want to characteristic, and there is a binary, and we want to make that people are sick or not. We have different examples: text categorization, the spam filtering, if it's spam or not, fraud detection, the card detection, that if that card is fraud or not, credit card fraud detection. Then optical character recognition. What is happening? That I want my answer sheet to be like the faculty has checked the answer sheet, but for totaling, it want people to I want to make a system for totaling uh, so that my answer sheet get uh, calculated automatically. So what we are doing, we are optically recognizing the character if it's 1 2 3 4 etc. Okay, then we have if it's 1 2 3 4, or if it's written okay or not. So we are we are recognizing the character. Then we have machine vision, like in which we are face detection, we are doing face detection, we are classifying the scene, etc. Okay, then natural language processing, spoken language understanding, then biometric information, classify protein according to a function, etc. So these are the other examples. So first we have spam filtering. So what happened? We have so all our system have spam. You've seen that in it is already filtered. So how they are filtered? The mail comes, and there are already some classification going on in the server to classify that. Okay, if this mail is from, so if this mail is from this type of email ID, or yeah, if the material written in the email is raw, can you review a paper? So this is not spam. But if the material has, the email ID looks genuine, but the material is earn money without working, so these kind of always thing are spam, so it should be categorized into spam. So the computer learns from examples to distinguish spam or not spam, and it always in our email system, so they're always applied at the server level. Then I talked about human language processing. So what is happening? How it works? So the human is speaking. Automatically, speech has been recognized. It is converted into text. Then it is predicted. Then the text is converted to speech, and then the computer is speaking. Like yesterday, sir told us that HDFC had converted his uh, uh, customer care to the all AI based. So this is the example. So what to do if data available is not images? Okay, so my problem statement is that I want to help a doctor. Okay, so there are many research going. You would have heard that there are many research going which are trying to help doctor with trying to help doctor. Okay, so they are having machine learning or deep learning to recognize if that MRI has tumor or not, with with the help of machine learnings to help doctors so that they can diagnose fastly. Like they're not trying to eliminate doctor or the radiologist, they are trying to help doctor and everybody. So what if you want to design, okay, I want to help a doctor, but the data which is available is not in the images. Okay, what should I do? So the data set. So I want to detect cancer. So the cancer of like the cancer is categorized into two things: malignant and benign. So this is the categorized. So this is a binary classification because it is categorized into two. Okay, so this is my data set. Like this is the example of data set. So I have a data set which is not an image, but this in a tabular form, and I want to make a system to help doctors to help. I want to make an app to help doctor so that the diagnosed they can diagnose fast. They can cater in number of many number of patients. So what I will do, I will use classification model. And then there is like we have n numbers of classification model, but among them we have one classification model known as SVM. So what SVM is? SVM is support vector machine. So our data is in two uh, it's binary classified. So it belongs to two class, and our data is linearly separable. So you can see this is my data, this is class 1 and this is class 2, and it is linearly separable. Okay, so what is SVM? SVM helps to classify data with the help of margin. So what happened? The data is classified linearly separated, then margins are made so that so that the data can be categorized. Okay, so SVM is binary classified, train on data from the two classes to find hyperplane with largest margin. So the larger the margin, the better the data is. Okay, and the data should be linearly separable. So these are the margins, and it should be the greater the margin, because if the margin will be here, so more data is in the margin. So why it is called support vector? Because the data on the margin are support, these are called support vector, and this helps to categorize the data, to categorize your to classify and categorize your data. So what if our data is not linear? I will go to that later. So first, my issue is what if that data is not linear? I will tell you later. So what if the data is noisy or I have outliers? Okay, so this is my hyperplane and this is my data. You can see that some green is here, some red is here, some red is there, but still I want to classify. So if my data is noisy or if I have outliers, so there are chances that data is prone to overfitting or being too sensitive or giving me wrong answer. So I want mm, uh, my model to be flexible, so that it, like if these are small issues, it's able to tackle that and classify it properly. Okay, so in support vector, we look for two things. First is setting of margin, and we want lower misclassification rate. So you can see that there is this margin: c is equal to 100, it is nearer; c is equal to 3, it is wider; and c is equal to 1 is equal to wider. So the larger the value is, smaller the margin is, because it is inverse, and smaller the value, the larger the margin. So you can see in this image, the margin is narrower, less data is under the margin. If the here the c is equal to 10 and more data is in the margin, and c is equal to 1, so more data is margin. So our main goal is our margin should be bigger. uh, okay, so how it is done in Python? I have a notebook. So before, okay, so before going to this, my model has been trained. Okay, so my issue was that I am okay. So my model has been trained. Uh, okay, so this is trained for 50 epochs. It was run 50 times, and the accuracy is saying that it is 98%. That 98% of time it will tell me right answer. Okay, so my problem statement was I've loaded only one image. So my problem statement was that if there is a cat or a dog, so the robot should notify because it's a no pet policy. So I've loaded my image. I have predicted. So model dot predict, and this is the result. And then I've printed the result. So this is the result. Okay. So the result will always come like this, and it's the work of the programmer to make sense of that result. So I've used if or else condition. If there is a cat or a dog, it is not allowed, else allowed. Okay. Uh, so there is no need, reason for else. I only want cat and dog to mention it's a cat and dog and it's not allowed. So you can see it saying cat or dog, it is not allowed. Okay, so I took the image. So the image is very small here. So it's an image of a cat and it detected correctly. So let's see if it's able to detect the image of dog. Okay, because so it's saying allowed, it's not able to detect the image of dog. The accuracy was less, so there is issue. So I will retrain my model. I will do some changes because there is issue while doing. You might come to this issue will come, and so you will retrain your model. You will change the layers. You will retrain your model, and you will again work with it. So until and unless the result is according to you, because accuracy will never be 100%, so there are chances for few errors to be there. So I was telling you about share this. So I was telling you about the SVM. Okay. So now these are all the imports. I'm importing the data set. This is model selection, train and split, because I told you initially, even for any data, I want to split my data and I want to split it randomly. So this is late, data for breast cancer. So I've categorized my data into X train and Y train, X test and Y test, and I've tried to split my data and I want it to be random. Okay. So we have the SVM is for SVC, because in SVM we can do classification and even regression. So for classification we have SVC. So this is a model. Okay. So this is I've called my model. Then I'm fitting X train, Y train, and then then I'm printing the score. So the score tells you the how high the accuracy is. So I was talking you about the value of C. So okay, so we have this help. Okay, linear SVC. Okay, so we have help, and help tells you that linear support vector classification. So help tells you the documentation I told you yesterday. So these are the various things. So I was talking about C. By default, C is 1. Okay. So by default, the margin is very broad. So if I change the value, if I make the value higher, if I make the value higher, so the margin will become narrower and narrower. So now I will change the value of C here. So C is equal to By default, it's 1. I'm giving it 10. So let's see what will happen. The percentage, there was no issue. Okay, 100. So no change. Okay, and 1000. So, yeah, it's not showing any changes. So it means so it means that even the narrower data, the data is very very I can say that the data is classified. It's because it's linear data and it's classified very properly. So even if I'm doing 10,000, the margin is very narrow, still no issue. Sorry, I need to wait. By default, it was the value didn't change. So the data is very, the data is very good and linearly separable, because the problem statement is we want our data to be linearly separable. Okay, so I told you like this thing in collab. Okay, so then our issue is what if the data is not linearly separable? What if the data is not linearly separable? So general idea is the original feature of the space can always be mapped to higher dimension. So we are changing the dimension. So the data is not linearly separable. So we are changing the dimension, and then what we are doing, like, see, it's form of circle here. Here it's in form of some hyperplane 3D image. So it always we try to do some higher dimension to include the feature space. Okay. Then we have a thing known as kernel. So okay, I'll show you this SVM again. So in the second one, you can see there is this kernel. So there is this kernel. So what exactly kernel is? So now our statement was, the problem was the data is not linearly separable. And in SVM, the first thing was the data should be linearly separable. Okay. So the first thing was the data should be linearly separable. So we want our data to be linearly separable, but it's not linearly separable. It is some form of, it's in form of circle, or it's 3D plane, and it's like it's being just, we are just organized. So we are trying to separate it. We are trying to separate the data, but it is not in a single hyperplane line. So what happened? We use kernel. A kernel function is a function that is equivalent to an inner product in some feature. So this is kind of, we can say the trick is that the kernel method represent the data only through pair of set of pairwise similarity comparison between the original data observation. So we have different type of kernel: linear, polynomial, Gaussian. So what happened? So now my data is this. Okay. So now back to this data. So I have for this, my import is SVC. Okay. So I've loaded the data. The process is same. And now I'm taking this SVC. And here I've taken kernel as linear because my data is linearly separable. I'm running it. Okay, so you can see that the percentage is almost similar. Okay, I will remove the value. I will change this value to 2.0. Let me delete this. Okay, so it increased. My margin got narrowed and it increased. So I'm using linear. Kernel is linear because the data was linearly. It's linear here. Okay, 3, 4. The narrower the margin, it's the probability is the accuracy is increasing. Okay, now I will change 10. it's not doing anything, so no issue. So I told you that I want my data to be random. So if I'll change this value, I'll change it to 100, even the accuracy will change. Okay. There are chances that accuracy might change because the data has been split randomly. So I will run it again. Okay, now the extreme white next test white test has been randomly split again. Now I will run this again. First, I will take it as one. Okay, so initially it's almost same, but initially it was around this was one. Now three, no change, no major change. 10, so no major change. Previously, when it was ran, the data was randomly, so the accuracy was reached till 97%. But now it's 90. It's still there. Like they both are matching right now. You can see the previous one. Okay, I will run this again. So you can see it's matching right now. Okay. Now, if I'll take it to 100, okay, 100 will be much narrow, 30. It's not increasing, it's not doing anything. So while running any of your model, even if it's deep learning model or this machine learning model, you'll have to make that accuracy higher, like as higher as possible. So you'll have to retrain your model again and again. So it has decreased. Now you can see when I've reached it till 100, it has decreased. Now you're like, okay, so the accuracy is between 30. Last tried 30 and 100. So, I'm taking it as 50. So it's same. So you'll see. So whenever you're doing a model, you'll be like, okay, my accuracy is not changing. So I should keep my accuracy between, like I should keep my, the margin should be between, the value of margin should be 50. Okay, I'll change value where C is equal to 10. It's same if I'll do C is equal to 100. Because the machine learning models take less time, so I'm showing you the hyper parameter tuning here. But in deep learning, it always takes time. If you're running in your system, it will take very much time. So it totally depends what system configuration you have. So yeah, sometimes model training in deep learning takes hours, 2 hours, 3 hours also. Okay, so no changes in 100. I'll change it to 50. So it is same. So like, okay, it can lie here. So help S VC S VC. So these are all the parameters this function takes. C is equal to 1, it is default. Kernel RBF is default. So these are all the values it takes. I'm not going into the deeper maths of SVC, but yeah. So it's a float value regulation parameter. The strength of the regulation is inversely proportional to C. So smaller the value, higher the margin. So these are the different kernel linear, polynomial, and radial bias function, which is by default in SVC. So what if our problem is multi-class? Okay, so we were dealing with two-class binary classification. What if our problem is multi-class? So what happened in SBM if we have a multi-class problem? It is one versus rest. So what will happen? It will take this as one class and these two as different class. Then it will run taking this as one class, these two as different class. Then it will take this as one class and these two as one class. So this is how multi-class classification happens in SVM. But by default, the approach is by default the approach like by default the ASPM classify binary, like it wants binary classification. Okay, so to tackle multi-class classification, what it is doing, it is taking this one class and combining this all. So this is known as one versus all problem. So I have one more thing for you guys to see. So okay, so I have this. So there is this classifier which is known as lazy predict classifier, and this classifier has been made by one person. And what happens? So I'm taking the same data set as previous. Okay, sorry, I'll have to load this. So I'm taking the data set as previous. So I'm splitting it. And what happened in, so this is a classifier. It is available on GitHub anybody is interested. If anybody is interested, he or she can look for this classifier and run it. So what happens? This classifier gives me accuracy for the few 200, sorry, 20, 30 classification model. And from that, I can make out, okay, so logistic regression is giving me 98%. This is one type of classification. So it is giving me 98%. So I can take this model and fine tune it. So this helps you save time, like when you are doing some model and if you want to check that which model, which five top five models or which top 10 models are giving good accuracy, so you can go. So in the SVN I was showing you, SVN it was giving 96%. So here also it's giving 96% prediction. So you can look into it, this lazy predict. So it's giving, so these are the different classifiers which are there. This logistic regression is also a classifier. So these are the different classifier, around 20, 30 classifier, but look into it. Okay. So this was lazy predict. So anybody has, okay. So there are a few questions that how the weight are determined. So it is determined using back propagation algorithm. You have no role. And the second question, how should I know if my neural network is not biased to anything? So we use proper evaluation metrics. Like what happened? We try to map it out. So whenever the output is, like whatever the output is, we try to map it out. Like we visualize it, and with the help of visualizing, we can see, okay, it's being getting biased or not. And if you think it getting biased, so you change the values, you change your layer, your neural network layer, you change the other all the things, and then you rerun your model, because you rerun it, and then you run accordingly, and then again you visualize it. So all the model training, even if it's deep learning or it's classification, sorry, deep learning or the machine learning, so you have to find the higher percentage accuracy by rerunning your model again and again. So created TensorFlow is something delicate for CPU. This is in the phase recognition code. Can you please tell me what it is? So okay, before that, does anybody has any doubt? Like it was like you guys were able to get it. Like if you want to do your some basic deep learning code, will you able to do it? Because you have two tasks. Like one task is to look for that mask and face mask. How will you do it? And the second is to run a classification model. Like you can use SVM, or you can do any classification. You can take any data. You can even take this data set and try to run it. So these are the two problem statements.
If anyone is having any doubts, please post your query in the chat box or unmute yourself and
Yeah.
ask the question to
Okay.
me.
Sorry. Sorry, I cut you. Yeah, you can unmute yourself. And I want that case Siddharth to unmute, and like I want to know what he wants to ask.
Siddharth, unmute yourself.
Good evening, ma'am.
Good evening.
Ma'am, while running that code, I got that info. Like it's running properly, but that is showing in the terminal.
Oh, which code? Like you were running a face recognition for the mask.
Yes, ma'am.
So you are okay. You are trying to run on TensorFlow Lite, so that it's light, like it's easy to run. Maybe it's not supported. So you're using your system, or using or you're using the collab.
No, ma'am. My system in PyCharm. I'm doing it by PyCharm.
Okay. So what are you doing? You are doing this is while learning. So maybe this can be based on the configuration of your system or the GPU or something. There might be issue with the GPU, like it's not supported by this. Try the normal TensorFlow, like if you have a nice configuration. So what's the configuration of your system?
I have GPU, ma'am.
Okay, you have a GPU. And which GPU?
Uh, AM something. Ma'am, it's AMD Radeon.
Okay. Maybe try the normal TensorFlow, because sometime it can have configuration issue. Try the normal TensorFlow. Don't go with the TensorFlow Lite. Because you have a GPU, so why are you going for the TensorFlow Lite? So anybody else have any doubt?
There is a request from Trilochan. He says, okay, he wants you to share the code. Okay, so as no one is having doubt, I just would like to request Aishi ma'am to share the code of the support vector machine as well as the image classifier so that students could practice. And thank you very much, ma'am, for sharing your knowledge and teaching the students about neural network, convolution neural network, and all about classification. Thank you so much.
Thank you, ma'am. I will share the code. There is a WhatsApp group. We have a WhatsApp group. So
Okay,
I will share that code over there.
okay, ma'am. Thank you, thank you.
Thank you.
Students, please ensure you fill the feedback form